So a linear function, something happened to my projector over the break. Maybe the custodians banged on it or something. They were cleaning. A linear, so I have to make sure I keep it on the. A linear function has the equation y equals ax plus b. Just stick with that for now. I know you're used to mx plus b, but you will see next year in grade 12 that the leading coefficient is usually called a. We refer to it as a. Okay, so where a is the leading coefficient. And I apologize, it did not leave you a whole lot of room there. The leading coefficient is the leading value in front of the highest power of x. It is, we really focus in on that because it tells us a lot of information just by looking at it. And the constant b is the y-intercept. So I'm starting with linear. It's like, hey, remember this? Okay, there it is. It produces a straight line since the highest power of x is 1. Okay, the highest power of x is 1. The equation has a degree of 1. And so this year we go up to 2. Next year you'll do 3, and maybe perhaps even higher. Okay. Note that y equals ax plus b can also be written as y equals mx plus b, where m is the slope and the constant b is the y-intercept. So that's still in place, but we're moving into calling that m, we call it a because we see a pattern. Okay, a quadratic function, right? Now we're talking quadratic. Okay, a quadratic function has the equation y equals ax squared plus bx plus c, whereas a cannot be 0. Everything else can be 0, guys. B could be 0, making this disappear. C could be 0, it would be not visible, but A cannot be 0, right? So B and C may be 0, where A is still the leading coefficient. Okay, and the constant C is the y-intercept. So that stays. So that last, the C is just a number, no variable attached to it. So that's what we call a constant. And that's going to give us the y-intercept. So let's write it down like this, 0, C. It's going to be 0 because x is 0 at that point and C is straight from the equation. Okay, it produces a parabola. Okay, it's a parabola that is formed. So not a line, but it's a parabola. Since the highest power of x is 2, the equation has a degree of 2. The quadratic function will always produce a parabola, right? Always produce a parabola. It points either up or down, and it expands sideways indefinitely. Okay, so it's important to remember. State whether the graph is one of the following functions. Is it a constant, linear, quadratic, or is it a not applicable? This one would be, this is what a parabola looks like. Okay, so this one would be a quadratic. Quadratic, and the degree is 2. Okay, this one for us is not applicable. Not applicable. This is a quadratic as well. And the degree would be 2. So if you know, it's almost like a horseshoe, right? A horseshoe is a parabola. It either points up or down, that's it. Can I add that to your notes here? So if you go under parabola, it's like a horseshoe. Okay, so it's either like this or like this. But it shouldn't be looking like a U, You know how u goes up and then they're like parallel? A parabola always opens up indefinitely sideways. Just remember that. This is a straight line, so this would be a linear function, right? And your degree is 1. If it's a linear, then x, there's an x in there, right? X to the power of 1. This one here would be a constant function. And what's the degree of a constant function? Anybody know? There's no x there, is there? It's technically x to the power of 0. X to the power of 0 is just 1. So the degree is actually 0 for a constant function. Not terribly important for you to remember that, but I just want you to notice the pattern because there's 0, 1, and 2. Right? This one is not applicable. If you have something that looks like a parabola that's pointing sideways, it's not going to be it's not a quadratic. Okay, it has to be pointing up or down. So if you want to like focus on quadratic, right? These are the only two that happen to be quadratic. And we notice because they look like a horseshoe and it's either pointing up or down. So let's fill in this chart. So if I gave you this and you were asked to find the degree of this, you would have to see that there's x with a power of 1. That's the highest degree of x. So the degree of this function is 1. It's a linear function. The leading coefficient, where is the leading coefficient when you look back to this? It's always in front of x, right? So the leading coefficient here is just 1. 1x, right? Actually, this is more specifically, listen carefully to this. The leading coefficient is found in front of the highest power of x. Does that make sense? So in this case, there is just x, so obviously that's the one we're going to pick. So there's a coefficient of 1. The constant in this particular case is 7, the one that just has the number by itself without a variable attached to it. So I just flipped it on you, and you got to be comfortable with it being switched up on you, okay? The next one here, there is technically an x to the power of 0 there, right? Anything to the power of 0 is always 1, right? So the degree here is 0. It's a constant. So without looking at the graph, just looking at the equation itself, you should also be able to draw this out. The leading coefficient here is 0. And the constant is 15. Okay. Next, look at the, you shouldn't also be worried about if it's f of x. It's just another way of writing y is equal to, okay? So don't let that throw you off at all. But the degree here, if you focus in on that, is 2, right? The highest power of x is 2. So this is a quadratic function. The leading coefficient is right in front of x squared, which is -3. And the constant is all the way at the end, which is just a -5. With sign and all, you got to be able to write that out. Here, the degree is 3. I'm not supposed to do this, but I will do it anyways. It's called a cubic. We will not be dealing with cubics. Next year you will. So I kind of give you a little bit of a hint is what's happening next year. Okay. The leading coefficient, just look at what's in front of x cubed, and that's 1. And the constant is not obviously there, but it is 0. It has a constant of 0. It's like plus 0 at the end. 1 over x, I will just say not applicable, okay? This whole thing, I'll just say it's not applicable. We don't deal with 1 over x, okay? We don't deal with that. And here's one where I was hoping that IPR, Intro to Applied Pre-Cal, do you remember FOIL at all when you just multiply it out? Let's do that real quick because I need you to be comfortable with that. You're not going to do a whole lot of FOIL, but let's just do it together, okay? So you basically go x times x is x squared. Let's do this. Let's put the 6 outside. The 6 stays outside for now. And then x times 3 is 3x, right? And you move over to negative 5. Negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Let's clean it up inside there. X squared. 3x minus 5x, you have minus 2x minus 15 there. And now we distribute the 6, right? So 6 times x squared is obviously 6x squared. 6 times negative 2x is negative 12x. 6 times 15 is negative, so right, 6 times negative 15 is negative 90. And when you have it in this form, you can truly answer the question. So what's the degree of this function? Dos, right? 2. And it's a quadratic. As soon as you have a power of 2, it's a quadratic. The leading coefficient is in front of the highest power of x, which is 6. And the constant in this case is negative 90. So you kind of have to do a little bit of work when I will show you a trick with the calculator after, so you don't have to panic too much. If you're like FOIL, oh, I don't like this, right? Like just hold on for a bit. We'll get you through it, okay? Next page. If you want to hole punch it, I think there's one right there somewhere, right here. So you can do that later. Unfortunately, they're still out of hole punched paper, so I can't order that. Okay, so in general, we have 3 forms of the quadratic equation. But I will say this, don't panic too much. All 3 can be typed into your calculator, and then it's easy peasy from there, okay? But I need you to know the 3 forms so you know what to do when you see them. So the general is the one we just talked about. It's y is equal to ax squared plus bx plus c. That's the most common one you're going to see throughout this unit, okay, most common. Then you have the descriptive or the vertex form. They mean the same thing, but the vertex form tells you that it will give you the vertex, right? So this is how that one shows up in general. So watch, it has the bracket and the square on top there. There has to be a square somewhere for it to work out. And the factored form is a, and then it would be x minus r, x minus s. Don't panic too much just yet. We're going to focus on the general for the most part. And what does each one of them gives you something just by looking at it. Okay, so this is what this one gives the y-intercept. And so just by looking at it, if you look at it like that, you're like, I know that the y-intercept is 0, c. You don't need a calculator for it. You could just look at it. It's like, I know what the y-intercept is. This one gives the vertex. That's why it's called the vertex form, by the way. And there's a bit of a trick to it. You need to take, and I will use red pen maybe for this one. You need to take whatever value you see in this bracket and you need to change the value. That's where the negative, the sign, sorry, just change the sign. So it's negative HK. And I will show you what I mean later on. Right now, this might be gibberish to you, but it will make sense later on. So if there had been a plus 5 in here, you would have to take it out and make it a negative 5. It's the opposite, okay? And then this one, factored form, gives x-intercepts. Gives x-intercepts. And they are as follows. The first one would be the same thing as you need to change the sign. Minus R0. And the second x-intercept, you're like, 2 x-intercepts, Mr. Dirksen? Yes, it can have up to 2 x-intercepts. You got to change the sign of S as well, and 0. Regardless, so technically, I want to say this. Technically, you can start with general and can rewrite it in vertex form, or you can rewrite it in factored form, but we're not going to do that. But there's a way to technically write. If you're given a general, you should be able to write it as a vertex or as factored form, right? They all should talk about the same parabola. But what I want to focus on more is if you see this, what can you get out of it just by looking at it? That's what I want to focus on today. Regardless of which one you're given, we simply type them into the calculator, right? And use second trace to find additional information about the parabola. Please remember that. Sometimes they look really scary. And I'm like, no big deal, just type it in. Type it into your equations, graph it, and let the calculator do the hard part for you, right? It's because you have a calculator that we can give you scary equations, okay? Most of the time, you'll be given an equation in general form, okay? We will start the unit by focusing on the general form and then add the other ones gradually. So I'll come back to these two later on, okay? There are some properties of the resulting graph that can be extracted by simply looking at the equation. So if you're given the general form that looks like this, there are a couple things you can tell right away just by looking at it. Okay? The direction of the opening, for example. The direction of the opening of the parabola can be determined by the sign, fill this in, by the sign of the leading coefficient, A, right? So if A is positive, the parabola will be opening upwards. You know that, right? Opens up. Okay? If A is positive, it doesn't matter what it is. It's a fraction, a decimal. You know if it's positive that it's going to open up. If A is negative for that reason, for that same, on that same token, right? It opens down. Downward or opens down, okay? So boom, just look at the sign of the leading coefficient and just remember, be careful. Some students think it's always the first number. I could sneak the x squared on the back of that equation. Don't, right? Look for the x squared. That's your leading coefficient, okay? The width of the parabola can also be determined just by looking at it. Okay, the leading coefficient determines the direction of the opening and the width of the parabola from end to end. Okay, to determine this, simply look at the value of A, not the sign. a parabola can be wide, normal, or narrow. Okay, so let's give you a little bit of a reference here. So wide, just make it look like a wide curve that goes like this. Okay, so this will take a long time to go up, right? Like it will first go sideways more than up and slowly result in parabola. So this would be one looking up, and you have another one that would be facing down, but regardless, both of them would be considered wide. Okay, and how do you know that? We look at A, right? So if A is between 0 and 1, if A is between 0 and 1, you know it's going to be a wider parabola. If A is equal to 1, it's going to be a normal parabola. So just make it look like this as best as you can, just something that looks like that. That's what we consider a normal normal parabola. And then we'll make the last one very narrow. Okay? That is when A is greater than 1. And so let's make it very narrow, like I'm just going to go right along like this. Doesn't matter if it's close to the y-axis or not. Just make it narrower compared to the other one. So there's like 3 categories for the width of the parabola. Why is that important? And I'll tell you why. For window purposes, adjusting your window, if you know that A is a decimal, then you know you're expecting it to take a long time to come back perhaps. You might only see it going up and then your window cuts off. You're like, okay, it's a wide one, so I'm going to really extend my X max or Y max or X min, right? So these are your 3 categories there. So let's recap. A tells you 2 things, the direction and the width. Okay, so I think that's it. That's all I'm going to add to this page. Next point, the y-intercept, and I already talked about this. Notice that a quadratic function will always have one y-intercept. It has to have a y-intercept because it will at some point, if it opens up, it's going to hit the y-axis. Okay? When the equation is in general form, the y-intercept will be 0c, right? Because it is a point on the y-axis. So I want you to make sure that if it's a point, you write it as coordinates, okay? And this is a point that I added towards the end. If you have brackets up here, right? But I made a mistake because I rushed on this one. It's on the right-hand side, not on the left-hand side. Okay? If the equation has brackets on the right-hand side of the equal sign, then it is not in general form. Okay? If it's brackets, it's not general, then we have to use, right? We have to use the calculator to come up with the y-intercept. You can't just look at the equation and be like, oh yeah, the y-intercept is right there. No, you can't, okay? You cannot. Prime reason is here. I'll just go back. You don't have to go to the first page. You don't have to go back. I'll just show you. Look at this one here. Would you be able to tell the y-intercept just by looking at it? No. It ended up being, when we did some work to it, it was -90, right? So that's what I mean by that. So as soon as you smell brackets, you see brackets, right? Calculator. And you can't get that out of it. So we'll fill in the chart below and we'll do a little bit of this work as well as it's needed, okay? So follow along. So we're gonna, for each of these quadratic equations, we're gonna figure out the opening, the width, and the y-intercept. possibly just by looking at it. The first two you should be able to do always. The y-intercept only if it's in general form. Okay? So let's look at the first one. Is this in general form? You might not be sure. Are there any brackets? So then it is in general form. Yeah. So I'll add that general. No brackets, general. Okay? Brackets, not general. There you go. Hopefully that helps you. Okay? So what's the opening? I looked at the leading coefficient, and this will be going down. Why is that? Because A is negative. I'll just make that as a side note there. And maybe before we move on, let me just do this for you here, real quick. You've seen me use Desmos quite often already. So let's just, I typed in the, I don't know why it's, I think that's just, yeah, there. So look at what happens when I change A back and forth, right? Maybe I'll do it by hand. So if the bigger the A value, the narrower it gets, right? If I make it small, the smaller, the wider it becomes. And look at what happens. Once it's 1, that's considered a normal. If you go below 1, it's wider again. So it'll be wider, wider, right? Until once it turns negative, then it points down, and then the same thing applies. The bigger the value, the narrower it gets, right? So that's what the value of A does. Okay? And look at what C does. If you focus on the y-intercept right here, it will change the y-intercept. As C changes, right, so does the y-intercept. So it will always, so see how it's 4.3? If you click right on there, the y-intercept is 4.3, right? If I change C to negative 4.6, you click on it, it's negative 4.6, right? So C is your y-intercept, and A tells us the width and the direction of the opening. Okay, let's go back to this part here. The width of this one, do not look at the sign, just look at the value. 2, right? So this one is going to be a narrow one. Why? Because A is greater than 1. Okay? The value of A without the sign is bigger than 1, therefore it's going to be a narrow one. So it's going to be pointing down and be narrow. Okay? What's the y-intercept? Who said 0? Somebody said 0, you're right. 0C, so it's 0, 0, because technically it's trailing, right? C is 0, it's just not on the paper, not on the equation, but it is there. Okay. Next, is this in general form? Yeah, no brackets, so we're good. General. Okay, and then I look at the sign of A, I look at x squared. Whatever's in front, that sign tells me. So this one will be going up. Why? Because A is positive. Is it going to be narrow or wide? And it's going to be narrow because A is greater than 1. That's my explanation for it. You don't have to, normally you'll just write it down. Just write down narrow, like I won't ask you to do this. And 0C is my y-intercept, and in this case, right, that constant is -2. Right, so you just type that in. Just get it right from the equation, no calculator at all so far. Next, is this one in general form? What's up with the t, Mr. Dirksen? Why is there a t? Why not x? Doesn't matter. It's still a variable that is being used. So general, right? No brackets. So this one is going to be pointing down because A is negative. This one is also narrow. Why? Because A, if you just look at 7.8, right, it's bigger than 1. And then my y-intercept is just going to be 0, 9, positive. One thing, I'm going to throw a curveball at you. But don't write this down because it's going to mess up your notes. What if I had put a 9x like that? You got to be careful that then it would not be 0, 9, right? Because that is not your constant. Your constant in this case is 0, right? So watch out for that. It has to be a number by itself so you can write it down, or else it's 0 in this case, right? Let's keep going. Is this in general form? No brackets, right? You bet it's general. You're just waiting for the one that isn't going to be, right? So this one, look carefully. X squared is right here. I look at the sign of my leading coefficient and it's negative. So this is going to be down because A is negative. Okay. Is this going to be wide or narrow? What do you think? This is going to be wide. Why is that? Because this is the explanation. A is between 0 and 1. It's 0.5 in this case, right? So it could be 0.1, 0.2, 0.30, all the way to 0.99, right? But if it's anywhere between 0 and 1, you've got yourself a wider parabola. And what's my y-intercept? It's not 18, right? It's 0, okay? You're pretty sharp after spring break. Way to go. Maybe that's what we need more often, right? Spring break every 3rd week or something. Anyways, this one is not general. What is this? Doesn't matter if you recognize it right away, but this is actually vertex form. How about we do this? Not general. For right now, let's just focus on not general. What does that mean? I'm going to have to use my calculator. That's what that means. So this is going to be down, opening down because A is negative. It's going to be a wide one because A is between 0 and 1. And this is a temptation that I see a lot. 0, -3, right? You'd be tempted to do that. 0, -3, because that's a constant, but it's not general. Can't do that. Let's grab our calculators here. Type that in. Let's do this first. Everybody press zoom and press 6. Zoom standard. Let's all start with the same window. Zoom standard. It doesn't matter what you have in your y equals. Don't worry about it. Now let's go to y equals. Clear everything that's in there. Make sure plot 1 is turned off. Okay, these should not be highlighted. And let's type in this equation here. So negative 0.91 brackets x plus 2 close brackets, and please don't forget the square here. That's a very common mistake that students forget that, so you have to actually square the whole thing. Press x2 and then you go -3. So make sure you check. And this minus is actually the minus, subtract. This first one has to be a negative, like the negative in brackets, or else you're going to get some kind of error when you're trying to graph, syntax or something. So let's hit graph. Everybody seeing that? This is the best thing that can happen to you. If you see the whole thing appear, you're like, okay, good. I don't have to change my window whatsoever. Okay? We're going to find that y-intercept. Second, trace. If you want to ever get something from your graph, second trace, we're going to go value. So 1, and x is equal to 0 when we want our y-intercept. So just make x equal to 0, hit enter, and you should get -6.64. I'll do it one more time. Second trace 1, x is equal to 0, it's -6.64, and round it to 2 decimals, right? So this is what I'm going to do up here. Second trace 1, x is equal to 0. That's what I did. Those are my keystrokes. I'm going to ask you to do that every time you need to use your calculator for it. And then you go 0, -6.64. Please use coordinates. because we don't want to mix up equations with actual points. Okay, so we have to use calculator here for that last one, and I left it for last because I wanted you to first be comfortable with just the general form, and here's one where you couldn't do that. Okay, where are we at? 130. Okay, so what I'm going to ask you to do for homework, part of your homework will be to do what I just did here, but do it with this chart down here. Okay, you fill in all of those things, and I will post the key after we're done here. Okay. Hint, hint, there are two that you're going to need your calculator for. I don't mind giving you that hint. Just watch out for them, okay? Doesn't matter how ugly they are, just type them in. But don't do it now, okay? Next page, page 4. So I'm downloading a lot of information, I know that. But that way we can practice a bit more and we can kind of apply these things that we've learned as I give you some examples, right? Okay, so now we focused mainly on things that you could have just take or you came up with them just by looking at the equation. Now you need your calculator for the rest, okay? So the vertex, for example, what is the vertex? Here it is. The coordinates x, y of the point where the parabola changes direction, okay? So I'm going to highlight that. It's basically where the parabola changes direction. Vertex is very important for us. It's very, very important. The intercepts and the vertex are very important to us. It can be the highest point or the lowest point. Okay? To determine the coordinates of the vertex, we use either second trace min or second trace max. Okay? You gotta pick the right one. Okay? What will I say here? If you select the wrong one, if you select the wrong one, your answer will be off. Will be wrong. Okay? So the calculator will still attempt to find the vertex, but it's going to be the wrong one. Or you might get an error message, and then you'll be very frustrated, right? So, and it's very easy actually to determine that. Watch this. So if your parabola goes like this, right? You graph it, and you might have to do some tweaking until you see it. But really, the value of a, right? If a is positive, right? You're expecting it to open up. You don't know where it's going to be, but it's going to open up. In that case, this is your vertex here. So you're going to use second trace min, which is 3. Second trace 3 is the min. So you just look at it and you're like, I know that. I know I have to use the min here. So don't use the max because it's going to be wrong. On the other hand, if you have one of these, then your vertex is right there. There's that point, like it keeps, if you go from left to right, it keeps going up, keeps going up, keeps going up at a point where it starts going down. That is what we call the vertex, right? And so you'd use second trace max because it is the highest point in this case. So it's either in the valley or it's at the peak of the mountain, right? Like it's either one of those. Oh, I will do this. A is negative, right? So you can either look at the graph or just look at the value of A and then you know which one to use. But you need to be able to see the graph anyway, so I like to refer to the graph more so. Okay. The coordinates of the vertex provides us with two additional pieces of information. I will come back to that graph. I will first talk about the two pieces of information that you're going to get. One is the equation of the axis of symmetry. The equation of the axis of symmetry, which I call AOS, axis of symmetry, but it is an equation. Emphasis on equation here. Right? And the equation of the maximum or minimum. The axis of symmetry. Do you remember symmetry? Symmetry is when you can cut something in half, right? And you have the exact same halves. So the parabola has a unique property that you can cut it in half along, right through the vertex. So watch, I'm going to use a red pen. You can use whatever color you have. But this line that cuts it in half vertically is what we call the axis of symmetry. So AOS. Okay. It goes through the vertex. And then there's a horizontal one that also goes through the vertex, like so. And I make them dashed because they're not part of the graph, but they're used to make references. So you almost get, right, a T there. I'll do the same thing with my second graph here. I focus on the vertex. I put my pen right on the vertex and try to make a perfectly vertical line like that that cuts your parabola in half. And I'm going to add to those in a bit. Right now, just focus on those two. So then you go back to the vertex and you make a horizontal line. Like so. So these are actually equations. Okay, they're not points. I will call this axis of symmetry as well. And so the axis of symmetry, I'm going to do this at the top here. This vertical line would be x is equal to, which one of these two values would I have had to use? I would have to use 2, right, as the, so this is the line x equals to 2, which happens to be the axis of symmetry. This is now the equation of the, it's actually the max, right, because it's the highest point. And that equation would be y is equal to 3, right, because it's the y equal to 3 line, like so. So the vertex gives you two things, the axis of symmetry and the equation of the min or max. In this case, it's the max, right? I like arrowheads on the ends of the parabolas here to be accurate. And then you have this axis of symmetry. You go to the vertex and it's negative 2.3, right? You go look at the x value. The y value gives you the equation of the, in this case, it's the equation of the min. It's the lowest point. And that would be y is equal to negative 3.5. So these are equations, these are not points. Okay, so be very careful with that. Can we write also that this is the vertex here? Like this is actually the coordinate of the vertex of this particular graph. And then we go up here and also add vertex, because that's very important for you to be able to just go to the graph and read it and you have all of those pieces there. So depending on which way it's pointing, you either call it the max or the min, okay? Again, the vertex gives you these two pieces of information, okay? And that's that for this page. Aren't you happy you don't have to graph this, right? It's just fill in. Just fill in. Next page. The x-intercept. Well, notice how it's x-intercept or x-intercepts because you can have more than one. Okay? Quadratic functions can have up to, right? Can have up to 2 x-intercepts. Notice a pattern for applied 40s. The degree of the function, the degree tells you how many x-intercepts are possible. So what are you going to do next year? Cubic, degree of 3. So you're going to have up to 3 x-intercepts possible. So that's a pretty neat pattern to see. So you can tell them I spoiled it for whoever's teaching it next year. So no x-intercepts. When is that going to happen? There are 2 instances. Let's first graph it. The first instance is for if your vertex is here, let's say, and this is another way of drawing your parabola. I go to my vertex and then I go this way, go back to the vertex, and I make the second half. It should look about the same. That's the definition of a parabola. It has 2 same halves. So that you would have no x-intercepts there. Alternatively, if you have the vertex below the x-axis and it's pointing down, right, that would give you no x-intercepts. Okay. Then there's a scenario where you have exactly 1 x-intercept. That's when the vertex is actually on the x-axis. So I put the point right on the x-axis. I'm going to make this one go up. And I'm going to go over to this side and I'm going to make that one go down. It shouldn't be a V, guys, okay? It should be like curved a little bit. So don't make a V or something like that when you graph it for ACs or whatever I'm going to throw at you. So notice the vertex is right on the x-axis. What do we call those points in general if it's on the x-axis? They're called x-intercepts as well. So the vertex happens to also be the x-intercept. So they share that title. And then you have 2 x-intercepts. You have the case where you might have the vertex below and then it's going to be pointing upwards like this. So you have 2 x-intercepts, or you have the vertex above and it's going down like this. So there are your 3 scenarios that you can have. I will add these 2 points here because I want to focus on the x-intercepts there. So how can you talk about this if I asked you like, hey, how could you explain when are you going to observe which scenario? Well, in no x-intercepts, you have 2 scenarios here. Vertex is above, vertex above x-axis, right? So this one, for example, vertex is above the x-axis and points up, meaning A is positive. Or you can say that vertex could be below x-axis and points down, meaning A is negative. Leading coefficient will be negative. One x-intercept, there's actually only one way. It doesn't matter which way it's pointing. The vertex is on the x-axis. It's on the x-axis. And notice that here, note, right? The vertex is also the x-intercept. So sometimes you're going to have that, right? Where the vertex and the x-intercept happen to be the same point. Okay, so that shouldn't puzzle you. That's just the case in this particular instance. And then you have this one where the vertex is below x-axis, and if it's below, then it has to be pointing up. Right, so if the vertex is below and it points up, then you have two x-intercepts. Or, and I will ask you your knowledge of this, and sometimes you have to actually write it in a sentence or two. So vertex is above, let's say, and points down. A is negative. So these are your three instances, right? So if it doesn't ever touch the x-axis, you just say not applicable. If I'm asking to find x-intercepts, you just say not applicable. Then you might have instances where you only have one, and you might have instances where, obviously, if you graph it, let's just focus on one. If you graph it, you're like, oh yeah, I can clearly tell it's crossing the x-axis more than once, right? So there we go. 0, 1, or 2. Here's some more information. Looking at my time here, I think this is where we're going to end. To determine the coordinates of the x-intercept or x-intercepts, we use, this is very important, so I'm going to highlight that. None of this is new, right? Like we've talked about how to do this. What is new is the potential of two x-intercepts, right? Like that, then you're going to have to do this twice, okay? So we make y2 equal to 0, and then we use second trace 5 to do that. Note, very important, you may need to adjust your window, right? Adjust your window in order to see the intercepts, right? The values of A and C can greatly assist you with this. If you know what A and C, what they do to that parabola, then you're like, oh wait, A is positive, okay, so I'm expecting it to go up. So if you just see a little sliver, you're like, I know it's pointing up, so I know which parameters to increase in my window or to change, right? So we'll do that. Determine the x-intercept, vertex, and I'm going to add one here. Find y-intercept also. And for y-intercept, there's only ever one, so you don't have to worry about more than one. Okay, so I'm going to focus on the x-intercept first. X-intercept or x-intercepts. I'm going to make y2 equal to 0, and I'm going to use second trace 5. I'm going to zoom into that because I'm going to stick to that for now. So let's go ahead and graph this, because that's going to be the tricky part. So let's, all of us, enter this into y1. Let me zoom out a bit for now. There we go, that's better. So I'm going to clear my equation. I'm going to go negative 9.85 x squared. Don't forget the squaring part, otherwise you're going to get a straight line. If you have a straight line, you forgot the x squared. Okay, remember that. And don't forget the x right after 15.05, right? And then minus 3. I will let y2 equal to 0 right away, because I'm going to need that anyways. And then you hit graph. And you happen to see it, right? It's right there. That's actually a good case, the best case scenario. So now let's figure this part out. Second, trace 5, right, for intersect. And if your cursor isn't on the screen, just keep going sideways and look at these x and y coordinates as you're moving. So for example, I'm going to make mine disappear. Mine is gone right now, and I notice that I'm at negative 38, right? So if I go left, I see it coming up to me. And then all of a sudden it appears, right? So which one do you want to find first? It doesn't matter. You want to find this one first? No problem. Just go as close as you can to it. And then hit enter, 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 just like we did before. Enter, enter, enter. And you write that down. It's 0. Watch the decimal, okay? It's negative 0.24. So it'll be negative 0.24. And y is equal to 0. So that's our first x-intercept. We're going to go ahead and find the second one. Second, trace 5. Now you need to go over the curve. I'm going to go over it and go closer to the other one. You don't have to be right on it, just get close to it. And then you hit enter 3 times again. Enter, enter, enter. And so the next one is negative 1.290. Boom, you got that done. We got both x-intercepts. We're good. Yeah. Yours isn't working? You go negative here. It has to be minus this one. Only the first one is yeah. That is a good reminder. Watch this. If you use a negative here, like if you use that negative instead of minus, it's going to be a completely different. It's actually a cubic. You just turn it into a cubic when you do that because it's multiplying. So it's a good reminder for me to remind you to use minus after just the first one has a negative. Okay. Hit graph. Okay. Now let's find the vertex. How do we find the vertex? We use second, trace. What are we going to have to use here? Second trace, is it a min or a max? Look at the graph. It's a max, right? It's the highest point. So we have to use second trace max. Don't use min, okay? Max. So let's do that on our calculator. Second trace max, number 4. And here you have to pay attention. So make sure you look at the screen now for this part. Okay. Watch what it says. It's saying, give me the left boundary of this vertex. What in the world is it talking about? I will put my pencil on the vertex. It wants you to go to the left of it. So I'm going to go my cursor and take it to the left of the vertex. So it says, give me a point that is to the left of the vertex. Okay, so go to the left. It doesn't matter where you go as long as you're to the left, and then hit enter. And what is it asking for now? A right boundary. It's saying, give me a point to the right of the vertex. So I'm going to go to the right, right? And then I can hit enter again. And obviously, every time you see guess in this course, you just hit enter, okay? And that is the vertex. Look at it, it goes to the vertex, and that's the coordinate that you should have gotten. So I'm going to write that down. Negative 0.76, and then it's 2.75. Notice that I'm rounding like that, okay? So that's the coordinate. So for now, if you didn't get it, if it didn't work for you, just write it down for now so you can go back later, okay? And then the y-intercept. And can I just cheat on this one? Can I just say 0, -3? Yeah, it's in general form. So it's 0, -3. But let's say you forgot that, right? Let's say today is the first day back, you're still sleeping, right? You're keeping your eyes. You just go second trace 1, let x equal to 0, and you get your -3 anyways, right? So you can use your calculator for all I care and still get that, right? So what I would like you to do, but I'm going to make a change here for homework. So that one chart I already told you about, and watch this. I'm going to make a change to this one, otherwise you're going to have issues. I'm going to say just add a +1 to this one. So on page 5, just add a +1 there. And I want you to find the x-intercepts, the vertex, and the y-intercept of this one. Okay, so that's your homework and the chart. And be ready for a small AC tomorrow as well with all of this kind of stuff, right? Thank you guys, you were great.